Hello and welcome to our lesson on ionic bonding. Ions. Metals will lose electrons to make positive ions and non-metals will gain electrons to make negative ions. Okay, so let's look at some atoms. What group is this atom in? Well, it's got one electron in the outer energy level, so it's group 1. Will it gain or will it lose electrons? Well, it will lose one electron because that's easiest. So what ion will it make? Will it be a positive one, won't it? This is lithium, so Li plus 1, but in reality anything in group 1, because they all contain one electron in the outer energy level, anything in group 1 would be a plus 1 ion. What group is this one? Well, this is group 2 because it's got 2 electrons in the outer energy level. Will it gain or lose electrons? Well, it would lose 2 rather than try to find 6 more to make it stable. So it would make a plus 2 ion. This is calcium plus 2, but again, anything in group 2, because group 2 means it has 2 electrons in the outer energy level, would also lose 2 electrons, and so anything in group 2 would form a plus 2 ion. Okay, so what group is this one in? Well, it's got 3 electrons in the outer energy level, so it's group 3. So it would lose 3 electrons rather than trying to find 5 more to fill up that electron energy level. And so it would make a plus 3 ionic charge. This is aluminium, but again, anything in group 3 has 3 electrons at the outer energy level, will always lose 3 electrons, and so anything group 3 will have a plus 3 charge. Okay, what group is this in? Well, this is group 5 because it has 5 electrons in the outer energy level. So will it gain 3 or lose 5, trying to make the 8 or get rid of it altogether? Well, it's going to gain 3 electrons, and so it would make a minus 3 ion. This is nitrogen, but again, anything in group 5 all have 5 electrons at the outer energy level, so they will always gain 3 electrons to become stable, and so they will always have an ionic charge of minus 3. So anything group 5, it will be N minus 3, it will be P minus 3, it will be AS minus 3, and so on. Okay, so what group is this one in? Well, it's got 6 electrons in the outer energy level, so it's group 6. Will it lose or gain electrons? Well, it's got to make 8, so it could add 2 or get rid of all 6. So it's going to add 2, it's going to gain 2 electrons. And so what ion will it make? It will make a negative 2 ion. But again, anything in group 6 has 6 electrons at the outer energy level, will always gain 2, and therefore anything group 6 will be a minus 2 ion. So O minus 2, S minus 2, Se minus 2, etc. Okay, what group is this one? Well, this is fluorine and it's in group 7 because there are 7 electrons in the outer energy level. Will it gain or lose electrons? Well, it would only need to gain 1 or it could lose 7. So it's going to gain 1, isn't it? So if it's gaining 1 ion, that would make it minus 1 because it's gaining that negative electron. And again, that means anything in group 7 is also going to have a negative 1 charge because they're all going to gain 1 electron to become stable. Okay, so here's a task for you, bringing together quite a few concepts that we've learnt about in this unit. It says draw a lithium atom, period 2, group 1. Use crosses to represent the electrons. Write the electron configuration below. And what ion will it form? Well, you're going to need to know this information from the periodic table to help you. So pause the video and have a go. Okay, so hopefully you've had a go. If you're not sure, let's have a look at this one together. So lithium atom, I'm going to start with my nucleus. I don't need to worry about what's inside the nucleus because I'm just looking at the electrons. So period 2 means I'm going to have 2 energy levels. It's group 1, so I'm going to have 2 in that first energy level and 1 in the second energy level. So that's group 1, 1 in the outer energy level. Why do I know I've got 3 in total? Well, because it says here I've got 3 protons and therefore I must have 3 electrons. I've used crosses to represent the electrons. Write the electron configuration. Well, that is 2, 1. 2 electrons in the first energy level, 1 electron in the second energy level. Now, what ion would it form? Well, it's going to lose that outer energy level, isn't it? it's going to form that +1 ion. Okay, so hopefully that's helped you a little bit. Why don't you have a go at the next one on your own? Okay, so have a go at drawing fluorine, and you will need this to help you. Okay, so fluorine, period 2, so I'm going to have 2 energy levels. Group 7, and it's got 9 in total, so that's 2 in the first energy level, and then group 7, so 7 on the outer energy level. And you'll notice I'm pairing my electrons. This makes it easy to make sure I haven't drawn too many. Write the electron configuration, so I've got 2 in the first energy level and 7 electrons in the second energy level. And what ion will it form? Well, it will gain 1 electron, won't it? They are, so -1, and that would be shown like that. Show that electron is coming from elsewhere, and I've shown it's coming from elsewhere because I've done it as a cross, so it looks a bit different. Okay, so pause the video and have a go at this one for me. Okay, so magnesium, period 3, 1, 2, 3 energy levels. It's got a total of 12 electrons, and that's group 2. So I know the first one must be full up, so that's 2. I know the second one must be full up, so that's 8. So that's 10 altogether, and it's group 2, so it's got 2 electrons in the outer energy level. 2, 8, and 2 makes the 12 that I can see there. The electron configuration would be 2, 8, 2. And it's got 2 electrons in the outer energy level, so it's going to lose those 2 electrons to form a +2 ion. And what would that look like if I drew that? Well, I would get rid of the outer energy level, wouldn't I? Okay, so have a go at this one for oxygen, please. Okay, so oxygen, again, period 2, so 2 energy levels. It's got 8 electrons in total, it's group 6, so the first energy level is full up, and the second energy level has 6 electrons, it's group 6. Okay, that's fine. Electron configuration is going to be 2, 6. And it's going to gain 2 more electrons, isn't it, to make it stable? So that's going to be O -2. What would that look like if I drew it? I haven't asked you to draw it. What would it look like if you drew it? Well, you would show those additional 2 electrons coming in there by using crosses, so I can see that it's come from elsewhere. It's not belonging to this oxygen atom. Well, the next obvious question then is, well, where did these other electrons come from, and where did the electrons that left, where did they go to? So let's explain this creation of ions. So here we have a sodium atom, which is a metal. It's group 1, so it's got 1 electron in the outer energy level. And then we have chlorine, which is a non-metal. In this example, it's in group 7. It's got 7 electrons in the outer energy level. So these are 2 examples. It could be any metal or any non-metal. So when they react, or when these 2 come in contact, sodium wants to be stable, and it will lose that additional electron, that electron on the outer energy level, making it positively charged. So it's going to be Na+1. At the same time, chlorine, which is also unstable and wants to gain 1 electron, will go, aha, there is a spare electron over there. I'm going to nab it. And it will gain and take that electron to become negatively charged, which is going to be Cl-1. So now sodium is stable but positively charged, and the chlorine is stable but negatively charged. Well, what do we know about positives and negatives? Well, then we know that opposites attract. The ions have opposite charges, and so they're attracted to each other, and they're held together with a really, really strong electrostatic attraction. And that is an ionic bond, and this is an ionic compound. And it's ionic because it contains ions. So our core concept then, ionic bonding involves the transfer of electrons between positive metals and negative non-metals to form strong electrostatic attraction. And that is the ionic bond, that attraction between the positive and the negative, and it's extremely strong. And that's why it's so difficult to separate a compound compared to a mixture, because the bond that is strong, the strong bond that's holding them together, requires so much energy to separate them. Okay, that's the end of this lesson for today, guys. I'll see you later.